Hello everyone, it is May 4th, which means it is Star Wars Day, so I just wanted to start by saying May the 4th be with you all. Thank you for coming together for yet another Swoosh hosted webinar. Today's event is going to be held by our application engineer, Collin Kopecky, and he is going to be discussing a wide range of capabilities and features within Solid Edge CAM Pro, as well as a session on hidden gems. So first I'd like to start off by mentioning a little bit about Swoosh, myself, and then we'll move on to the software expert himself, Collin Kopecky. Please note that you can ask any questions throughout the entirety of this event. You can just toggle on over to the Q&A tab, ask your question there, and then Collin will respond to those at the end of this webinar. Please ask away, and our goal today is to have you leave here feeling like the latest software Jedi. To begin, Swoosh is a team of highly knowledgeable members from all areas of the country with specialties in Siemens NX-CAD, NX-CAM, Solid Edge, and Team Center. With over 185 years of combined experience, we've earned the title of an award-winning Siemens Platinum Partner. And one of the greatest reasons I think that we are more than just a software company is our team's ability to mentor and deliver top-notch training to support our customers. My name is Karina, and I'll be your host for today's event. With over 3 years of experience in marketing, my specialties lie in video development, strategy, and content creation, bringing you the best and latest news in all things software, while providing beneficial insights for how you can grow as a team and individually. The Solid Edge CAM Pro Jedi himself, Collin Kopecky, takes it a few steps further with over 15 years of manufacturing experience and achievements such as implementing profitable processes into multiple business plans across companies. Last but certainly not least, Swoosh has a plethora of resources available to you, all accessible via our website at www.swooshtech.com. Everything you see here listed, from newsletters to blogs and class training, are all options available to help you and your team succeed in learning new skills. So feel free to go ahead and check this out in a different tab right now, or you can, of course, go ahead and look at this after this webinar has concluded. Now I would like to turn this over to Collin Kopecky so he can cover Solid Edge CAM Pro features and hidden gems.
Hello Karina, thank you for the introduction, and thank you to everyone who's attending the CAM Pro webinar. My name is Collin Kopecky. I'm based out of Milwaukee, Wisconsin. I'm a CAM applications engineer at Swoosh Technologies. Prior to working at Swoosh, I was in the consumer product industry for the past 15 years. Solid Edge CAM Pro is Siemens' solution for Solid Edge users to create CAM programs. Solid Edge seamlessly interfaces with CAM Pro, making job preparation quick and easy. You can create your manufacturing setup within Solid Edge and transfer that information into CAM Pro. With the manufacturing setup in CAM Pro, you can easily create accurate and concise shop floor documentation for your machine tool operator. CAM Pro creates toolpaths directly from the part and assembly models to help ensure accurate and efficient manufacturing processes. There are a variety of options within CAM Pro to control your toolpath. You can specify solid model work holding to avoid collisions, or take advantage of the in-process workpiece to optimize the toolpath based on the current stock conditions. Once the programming is complete, with CAM Pro simulation, you can validate the program using full G-code based simulation, and that will detect any sort of collisions or machine access violations based off of the kinematics of your machine tool. With all the tools available within CAM Pro, you'll be able to provide an accurate and validated NC program to the machine tool operator that will reduce setup times and maximize machine uptime. Looking at the manufacturing workflow with Solid Edge and CAM Pro, you'll start at the conceptual phase. This would be more of a manufacturing engineering role. This is where you would determine the work holding, stock conditions, and general setup within Solid Edge. That information would then be transferred into CAM Pro, where you can begin job creation. This is where you would determine the tooling used and create the toolpaths directly from the solid models and assemblies. While creating toolpaths, CAM Pro has a variety of options available to validate each individual toolpath, and will be able to detect any obvious issues using the internal toolpaths, checking against the assembled models. Once programming is complete, you have a variety of options to create setup instructions to pass along to the machine tool operator. Before the NC code is released, using CAM Pro simulation, you will be able to check the validity of the NC program on a true digital twin of your real-world setup. And finally, with setup instructions and a verified program, the operator will be able to quickly and confidently set up and run the job. Solid Edge CAM Pro is a modular programming solution. Additional licenses can be added depending on your organization's needs. Starting with basic prismatic part 2.5D milling, you can create single or multiple stage programs, fully taking advantage of collision avoidance and in-process workpiece transfer. With additional licensing, you can expand the capabilities of CAM Pro for more complex 3 and 5 axis surfacing toolpaths, or more specialized toolpaths to create industry-specific parts such as blisks and impellers. CAM Pro is not limited to milling. You are able to create 2-axis turning toolpaths, as well as more complex dual spindle, dual turret, mill turn part programming. With your program complete, Siemens offers pre-configured post-processors for a variety of machine tools. These are available directly from CAM Pro with PostHub. Additionally, you can create robust shop floor documentation and provide a validated NC program using CAM Pro simulation to reduce setup times and ensure NC code is correct the first time. Now let me demonstrate for you the process in which to set up a manufacturing file within CAM Pro. I'll start by using the Solid Edge to CAM Pro interface to move our assembly file from Solid Edge to CAM Pro. I'll then define our part in stock and our work holding for use when we create toolpaths, and then I'll import tooling from our library. I'll then go ahead and demonstrate how to create work instructions to be passed along to the operator using the drafting tools that are available to you within CAM Pro. Here we are in Solid Edge. We can see we have a fully assembled part. We have our work holding with vise and jaws, our part stock, and our blank, all defined within Solid Edge, and using the relations to assemble our assembly. We can move this information into CAM Pro very easily from the tool tabs on the ribbon bar. There's a CAM Pro interface, and that brings our assembled model into CAM Pro. I'll use this information to create a new setup file. And we can begin preparing our file for manufacturing. I'll go ahead and define my solid geometry. I'll start by defining my part stock and then my blank stock. In doing so, this solid geometry is going to drive our toolpath. So with our blank stock, our toolpaths will be limited to just that blank stock without any additional settings. It's going to automatically recognize the blank stock and limit the toolpath to cut just in those areas. As well as I'm adding check geometry, and check geometry is going to avoid cutting into whatever geometry I've specified. So I specified my jaws and my vise. Next thing we'll need to create toolpaths is tooling. CAM Pro, you have the ability to define your tool once and save it to a library, and then retrieve those tools in a new setup file. Here I have 5 tools. I'm going to import all 5 once. And now we have the tools necessary to start creating operations. Before I do so, I'm going to create setup instructions using the drafting tools that are available within CAM Pro. I'm going to start off by creating a draft for the assembly of our work holding. So I'll lay down a few views, and you can have whatever information you deem necessary for the operator to make setup as easy as possible for them. So I have a top and side view and an isometric view to give them a good idea of how the part should be placed, what jaws to use, and so on. You can go ahead and add some setup notes. Just have a generic message there. It can be as detailed as you want. Additionally, I'm going to create a draft for our blank stock. Again, the more information, the better for your operator for quick setup. So they have all the necessary information. They're not searching around. What's the size of my blank? What jaws should I use? All of that will be provided to them with these setup instructions. Again, here I'm creating a draft for our blank. I'll lay down a few views. We can add in some dimensions so the operator knows what size material this is programmed for. And if that matches at the real world setup, at the machine, they'll know this is good to run. So we have our two different views created. We have our geometries defined, and we have the tools necessary to create operations. With Solid Edge and CAM Pro, you can easily program off a solid model assembly. Having mirrored the assembly that will be on the machine in the real world, we are able to provide detailed setup instructions to the operator. The operator easily will be able to identify the necessary fixtures, tools, and equipment required to set up and run the job. This will reduce any concerns the operator may have and minimize setup times. Moving on to toolpath creation, I will demonstrate the ability to easily create toolpaths. The toolpaths will be based off the solid models, both the part geometry and blank geometry we specified previously. CAM Pro utilizes what is known as in-process workpiece, or IPW. IPW starts as the initial state of the blank geometry. Each operation that is created removes material from the IPW. The material that is removed is tracked in each subsequent operation. This means the toolpaths will be optimized for the current state of the IPW, reducing any unnecessary air cutting. Additionally, the IPW can be transferred to subsequent operations, removing the need to create the secondary operation blank stock. Now we'll jump into Solid Edge and I'll demonstrate the programming of this part as well as moving the IPW to the secondary operation. Now that we're back in CAM Pro, I can demonstrate how easy it is to create operations. I'll start by creating a facing operation to remove the material from the top of the part using a face mill. To create operations within CAM Pro, these are volumetric based. Your selections are going to be based off of your part geometry. So we need only to specify the cut area floor, and I'll select the top surface of our part. We can go ahead and generate, and we have a nice facing operation. The next operation I'll create is a drilling operation, and we'll drill out the center hole of our part. Like before, we need only to specify a face of what we wish to cut. In this case, I want to select a portion of the center hole, and I'll make a few setting changes. One thing to point out, we see this purple cylinder. That is indicating the material that will be removed from our IPW. We can take a look at our current state of our in-process workpiece. And we'll note that the face material has been removed, as well as the material removed from our drilling operation. And now each subsequent operation that I create will see that that hole has been removed and base the toolpath off of this current state of the IPW, this pink geometry. I'll go ahead and create a roughing operation to rough out the hex and that center bore. And for this, I'm going to use an adaptive milling operation. And this is a relatively new style of operation. This is more of a tricordial style toolpath, where it's taking in consideration chip thinning, and you're typically able to, if you're using a solid carbide end mill, usually use your full flute length of your tool and take a very small step over. And with that, you're able to achieve very fast feed rates to remove your material. I've had great success with this in the past on a variety of materials, both ferrous and non-ferrous, to really rough out my material very quickly. We can see based off very few selections, we have a very nice toolpath that's roughing the profile of the part, the hex, as well as our center counterbore. Moving on, I can create an operation to finish the profile of our part. Just to verify some of our location settings are properly set. How CAM Pro works is there's a hierarchy. You'll have a parent, and it's going to inherit the information from that parent down to the operation. CAM Pro uses something called methods, and with that method, it's going to inherit the stock allowances into the operation. So with a finishing method, we will not see any stock. It's going to cut right to the wall geometry. Based off of specifying my wall geometry, I have a very nice profiling toolpath finishing the outside of our part. I'll move on and I'll create a floor finishing for our hex step, this outside area that contains our drilled holes. Like we've previously seen, we need only to specify what area we want to cut. So I want to cut that step there. And if we want to limit our toolpath to just this outside area, we will need to specify wall geometry. Just to demonstrate, we can use this toolpath to fully machine both our the step on the outside of our hex as well as this inside diameter. However, I just want to finish the floors of the outside, so we would need to specify wall geometry. We could do that manually, selecting each surface, or there's the ability to automatically detect the walls. And if I view what CAM Pro automatically selected, it went through based off of our initial cut area floor selection and selected all of the walls adjacent to that floor. I can add some part stock to the walls, and we can finish that with a profiling operation. So if that was a critical tolerance that you wanted to cut with a secondary tool, or have a spring pass, adding some stock on this floor finishing pass would be ideal. Next thing I'll do, I'll create that finishing pass for the hex. And like before, we're able to only specify our cut area floor. and toggle on automatic walls, and CAM Pro, again, will automatically detect the walls adjacent to our floor. Once we generate, we have a nice profiling operation to finish the hex of our part. Moving on, we can create a hole making operation to mill our counter bore. And we'll make our selection of our counter bore. We can change our cut pattern type to circular. So we'll just plunge down to the bottom of our part and take one pass, removing that material. Looks good. Last operation will be our drilling operation for the 4 outside holes. Specify our tool and go ahead and select those 4 holes. And again, we can see the material that is going to be removed. Since this is a through hole, it is going to place our drill below the bottom of that shoulder. However, you do have the ability to control the depth manually. Let's say we want to go slightly deeper. We can easily do so. And here we'll want to deburr our part. And there's an operation within CAM Pro, Planar Deburring, that will go through and automatically detect every single edge that can be deburred based off of our settings. So we'll give this a depth and a size of our chamfer. And we're going to go through our entire part, and it's going to see all of the edges that it can create a deburring toolpath on and automatically do so. So now our part has been completely programmed. We can run this through our toolpath animation just to visualize the material removal. So we have our facing, our adaptive milling toolpath, our wall profile. We're finishing the floors of our hex and then going back and finishing the profile, and then drilling and deburring our part. Looks good. This first operation is now complete. We can move on to our secondary operation. I'll jump back into Solid Edge. Here we have a second assembly. This would be our second operation. We have our part positioned correctly. We can bring this back into CAM Pro using the Solid Edge to CAM Pro interface. And like before, we can create a new manufacturing setup using this information that was assembled from Solid Edge. One thing to point out, this time we did not have any blank stock within Solid Edge. That's because we're going to utilize the final state of the IPW that was created in our first operation. So I'll go ahead and specify my part. And then when I'm specifying my blank, there's an option for in-process workpiece. And in here we can specify our source. And then we're going to specify our first operation that we just created. And then we'll specify our orientation. And once I bring that IPW in from the first operation, we can see our part, or our IPW is now positioned correctly. And there we have the final state from the first operation automatically brought into our secondary operation. So we're going to have a very accurate representation of what material we need to remove. One nice tool with CAM Pro, if I go back and do my first operation, I can copy all of those operations. So any setting changes I made here, I can copy into my second operation. This is not only going to bring in tooling, the operation, it's also going to bring in the tooling as well. So I can go through and just make some setting changes. I'll have to respecify my cut area floors. So here I quickly created that facing operation just by reselecting. We don't need that drilling. I will use this adaptive milling one more time. I will just need to make one setting change, and then I can regenerate. And then we have all of that information that was set the first time, and we just copied it over and quickly created that second operation. And then we can go ahead and use our finished floor, select our operation. Our automatic walls was specified the last time we created that operation, so it automatically detected the walls adjacent to that floor. And just going through, we can, again, make some additional operations. We'll do a wall profile for that diameter. Just going through and using the same operations to finish our part. Some of these I'm moving to unused since we don't need them. We're not going to need drilling. One other option you have within CAM Pro is you can copy and paste operations from the same setup file. So I'll use that wall profiling for that bottom diameter. I'll use that as well on the top step. So you're very easily able to create operations based off of actual geometry selections. Again, very quickly. And then again, we can use that planar deburring operation. I can just regenerate that one. No setting changes are needed. One thing to point out is I never went through and specified my check geometry, so it is trying to cut into my jaw. To demonstrate what that looks like, if we had specified that initially, we can see all of our operations go out of date since something has changed and it needs to regenerate those toolpaths. Since we added that check geometry, it's going to want to go back in and verify all of the operations aren't going to interfere with our jaws. Once that planar deburring operation is regenerated, we'll see it will avoid cutting into our jaws. And it's getting as close as possible without colliding. So if I place that near that operation, we can see, yep, we now have a collision-free toolpath. With CAM Pro, you can easily create toolpaths based off faces of solid geometry. The operations are based off of the in-process workpiece, and the toolpaths will avoid any unnecessary cuts since it is looking at that preceding operations IPW. The IPW can be transferred from one operation to another. This is going to save time having to create any extra geometry. As well, you can be sure that the blank stock used in that preceding operation is accurate since it is referencing the first operation. As well, some other time-saving abilities in CAM Pro. You can copy operations from one setup file to another. That's going to reduce the need to make setting changes, saving additional time programming. With CAM Pro, not only can you create setup drawings, but you quickly can create tool lists and work instructions to provide to the operator. The work instructions can include detailed tool lists and detailed operation lists. As well, CAM Pro is directly interfaces with Solid Edge. So if there's a revision change made to the part model, the toolpaths in CAM Pro will be automatically updated based off of those revision changes. Here I'm back in my first operation. In here, if you remember from earlier, we did create some setup drafts. I'm going to utilize those drafts when creating work instructions. So I'm going to create both a tool list and an operation list. I'll start with a tool list. And here we can reference those two sheets that we created, one of the setup itself, and then one sheet for the blank. We can take a look at this tool list with a preview, and we can see both sheets are imported, and we have every tool that was used in this setup, as well as the operations that tool was used. We can take this one step further and create an operation list. Here we can select a view or take a screenshot of how we currently are. We can enter in any text for the operator. And then we can go ahead and publish this documentation. There's a variety of choices. You have HTML, PDF, or Excel files. And take a look at the preview HTML file that's created. And we have two different sheets created. There's our tool list. Then we have our operation list. With the operation list, you'll have each operation that is created in its order, and whatever description you might have added, as well as a toolpath times. Very useful tool, very helpful to the operator. As an example, we can imagine that there was a revision to our part. So if I jump back into Solid Edge, here we have our first operation. We can go ahead and make a few changes. Let me hide the blank stock. Then I'll go ahead and edit my part geometry. And I'll just move a few faces just randomly. We can change diameters of holes if we needed to. We'll say our larger counterbore diameter is now 65 millimeters. We can elongate our part. And let's say we didn't want that hole anymore, we could remove that hole. Looks good. We will need to modify our blank stock as well, just so we have enough material. And with our changes, we can see we have a lot of extra stock on the ends of our part. That's okay. CAM Pro will automatically recognize this. So I'll go ahead and save the changes that I made. And I'll use the Solid Edge to CAM Pro interface tool once again. And it's going to go through and update our existing setup within CAM Pro. And with everything updated, we can go ahead and regenerate our toolpaths. We can see as it's generating, everything is adhering to the new model definitions. The hole that has been removed, the hole that was removed is no longer being drilled. We now only have the 3 holes. I'll just cycle through. Maybe I'll toggle off my blank stock so we can see our toolpaths a little easier and how they were updated. We're facing and drilling, and our adaptive milling operation is now updated to that new blank stock. Same with our wall finishing toolpaths. And again, the holes that were removed were also updated. Then we'll take a look at our secondary operation. That will be updated as well. We will have to redefine our source. We'll have to update from our source. And once we make that update, we can see the IPW changes made from our first operation are now transferred over. And we can again just regenerate these operations, and everything will be updated accordingly. So not only if you have a revision change on your first operation, not only will that change your first operation, but it will also change your secondary operation as well, and update that IPW if you are referencing a previous operation. With CAM Pro, since you are working in the context of a physical assembly, you can provide accurate and concise and easy to understand work instructions to the operator, and this will minimize setup times at the machine center. The operator will have all the necessary information on the items required to set up the machine with work holding and the tooling information, as well as all the tool paths that will occur in the program. If a revision occurs, the models in Solid Edge are fully associated with the models in CAM Pro. You will need only to regenerate the operations and everything is updated, saving time reprogramming if changes occur. Taking verification one step further, CAM Pro can fully simulate the kinematics of the machine based on the post-process G-code. Simulation will fully detect any collisions that may occur and will detect any limit violations. It's better to have a crash on the digital twin and not in the real world. This is going to save on expensive crashes and an unnecessary downtime. Let me show you simulation. Back in CAM Pro, here we're in a new part file. This is a more complex aerospace style part. And this is the secondary operation of that part. Just want to point out that the IPW will transfer on more complex geometries. That first operation had a bunch of multi-axis surfacing toolpaths. So that IPW, if you were to recreate this, it would be very extensive to get an accurate match from that first operation. Utilizing the in-process workpiece from that first operation is sometimes absolutely necessary if you want a very accurate representation. Next thing, I'll jump into the CAM Pro simulation. And what this is going to do, it's going to post out the G-code that we would provide to the machine tool operator and run through and move the kinematic model based off of that G-code. And this is going to have an absolute representation of what would occur at that machine tool. Here we go. Looking at this NC program, we can see our code has been posted out. We can also toggle on our machine status. We'll be able to see where in space our tool is, and our table, and all of our accesses on our machine. Here we can toggle on material removal. That's going to show the IPW from that previous operation. And we'll play this through. This is going to demonstrate some of the additional modules that are available within CAM Pro. There is a multi-axis deburring operation that will quickly go through your part and create deburring operations. Works very similarly to the Planar Deburr. It's going to automatically detect the surfaces on your model that can be deburred. But that is definitely one of the more advanced type toolpaths available when you purchase those additional modules. In this particular program, there are no collisions. If a collision did occur, there would be a warning. The model would turn red, and it would point out exactly where that collision is occurring. Here we have that more complicated multi-axis deburring toolpath. All of the retracts were automatically calculated based off of a value. Here we can see our machine fully moving in 5 axes. With CAM Pro simulation, you can fully simulate the kinematics of the machine based on the post-process G-code. Simulation will fully detect any collisions that may occur and will detect any limit violations. Since your real-world machine kinematics match your digital twin, you can get a very accurate cycle time before running at the machine. This will assist in costing a job, eliminating the guesswork of what the actual cycle time is. With the G-code based simulation, you can provide the operator peace of mind when running the first article part program. To summarize, CAM Pro will offer a competitive edge when creating CAM programs. You can do all of the job planning within Solid Edge, taking advantage of the robust assembly relations. CAM Pro is model-driven CAM solution with easy toolpath creation. Many of the operations within CAM Pro, you will only need to select one face of the model to create a collision-free toolpath. CAM Pro's ability to track the in-process workpiece from one operation to the next will eliminate unnecessary toolpaths. Also, the ability to transfer the IPW from one setup to another will eliminate the need to create extra geometries. You have the ability to provide concise and easy to understand work instructions to the operator. That will minimize setup times at the machine center. As well, with G-code based simulation, you're providing an error-free program, free of any collisions or limit violations. Combined, all of these tools within CAM Pro will provide a significant time savings when programming and running parts at the machine. In this segment, I will cover some commonly overlooked tools in CAM Pro that will help increase productivity. I'll demonstrate the reuse library, how to copy operations using transform, the ability to mass edit operations, and compare operations from one operation to another. Finally, I will end with using a solid model tool holder provided by the manufacturer to easily define the holder steps when creating a tool assembly. The first hidden gem I would like to show you is the reuse library. The reuse library is a hidden tab on the resource bar that is off by default. Having all of your commonly used fixture models stored in a central location, the reuse library will reference that location to import your fixture models. Once the tab is added to the resource bar and the folder is referenced, adding a fixture is as simple as dragging and dropping into your workspace. With the fixtures imported into CAM Pro, you can easily assemble the model using CAM Pro assembly constraints. Following the reuse library, the next hidden gem I'd like to show you is the tool used to copy operations. The transform tool has multiple settings on how to transform an operation. You have move, copy, and instance. In the example I will show you, there are multiple identical parts in one assembly file. Rather than programming each part individually, transform will allow you to copy already created operations onto multiple parts. With this option, instance, the copied toolpaths will remain associative to the original operation. Let me demonstrate the reuse library and the transform tool. As I mentioned, the reuse library in a fresh installation of CAM Pro is off by default and will need to be toggled on from the resource bar. So on the resource bar, if you right click, you have some options to toggle on and off tools. Here we can see the reuse library is off, so we'll toggle that on. And while we're and now when we toggle that on, a new tab has been added to the resource bar, and we can begin selecting our folder that contains all of our fixtures. So again, if we right click in the open area of the reuse library and select library management, we can add a new library and browse to the location of our fixtures. With the folder selected, we can see we have a new library available to us. And in here, we can browse to the fixture that we want to bring into our assembly. There's some additional options to view what you're importing. We can see a small thumbnail of the model. And if we expand the preview window, we can see a larger version of that thumbnail. From here, this is the model I want to bring in, so I'll just hold down the left mouse button and drag it into my workspace. And the model and assembly is automatically imported. I can use the tools available within CAM Pro, the assembly constraints from the assembly tab on the ribbon bar, and quickly position our part. I'm going to position this assembly to the center point of our machine tool, this datum that already exists. And then we can use this fixture later down in our next example. With our fixture positioned correctly, we can begin bringing in our part components, our stock, and assemble it to our fixture. Moving on, I'm going to demonstrate the transform option within CAM Pro. This is the activity from our previous session. We have our part completed. However, there are two additional fixtures added. Rather than having to go back and programming each one of these operations individually, we can use the transform tool to have this done automatically. So I'll select all the operations I wish to copy, and then right-click Object Transform. And we're going to move this in the Y direction. Right now, I could take a guess at the distance, or I could use the Measure tool under the Analyze tab to find out this value. So I'll go centerline to centerline to get this value. So we have a distance of 300 millimeters. So this is going to be the total distance. So we have 300 to there and then 600 to the second fixture. So we'll have to add in that value. And then we'll have to specify the number of instances we want to create. That's going to be 2. So it is going to copy that toolpath at 300 millimeter increments. Now with our toolpaths transformed as an instance, if I wanted to make a change, let's say this face milling I don't like it getting so close to the other part. I can go ahead and change the position of the parent operation, the one that we transformed, to change that that cutting vector and regenerate that one operation. And I'll go ahead and inspect the rest of the operations. We can see it's automatically updated on the other two. Because our preceding operations are referencing the in-process workpiece, all of them will need to be generated since something has changed to the prior operation. We can see the instance toolpaths are doing one part at a time. So you would have to reorganize manually just so you're machining in a good order rather than tool changing back and forth. In this next example, I'll demonstrate a different method to organize your program when you are doing a transform. Here we have our assembled fixture from the reuse library and toolpaths already applied. So again, I'm going to highlight all of my operations. Mouse button 3, object transform. And rather than using a vector translate, I'm going to do a rotate about point. And I'm going to specify the center point of my fixture. And now we have our toolpaths transformed, and they are in the proper order. We are going to be facing and then changing the tool, do all the roughing, just so you don't have all this wasted motion and you're not having to manually reorder your program. If you have each operation in a program group, it's going to place that instance of the operation within the program group, maintaining that good workflow without having to reorganize manually. If the manufacturing setup is not created with the solid edge part file, using the reuse library to assemble your digital twin within CAM Pro will allow you to quickly locate and add fixtures that are required to set up the job. As well, the ability to transform operations as an instant will allow accurate and associative toolpaths to multiple parts. Rather than programming each part individually, transform as an instant will allow you to duplicate toolpaths while remaining associative to the original operation. If a change needs to be made, you need only to change the original toolpath and all instances will automatically update. The next two tools I would like to show you deal with the settings within an operation. The Mass Edit tool will allow you to change multiple operation settings with ease. Rather than editing each individual operation, the Mass Edit allows editing several operations at once. With Compare Objects, if you've ever had two operations that are seemingly the same but produce different toolpaths, Compare Objects will assist in determining what settings are different and need to be changed. Let me show you Mass Edit and Compare Objects. I'll now demonstrate the Mass Edit tool available in CAM Pro. Here we have a part already programmed. We have 6 similar operations facing off the material of our part. I could go in and edit each one of these individually. For example, if I wanted to lighten up the step over, I could go through, make that change in each individual operation. However, with Mass Edit, you can highlight the operations you wish to all change and select Mass Edit. We can see when we're in the Mass Edit dialog, we are missing some tabs. It's only giving us the options that can be changed for each individual operation. So it is an abridged version. It's not going to allow you to change something that's going to break the toolpath. So in this example, I'll just change the step over from 75% to 50%. And OK the dialog. We can see all 6 operations went out of date. I can go ahead and regenerate those operations, and the step over will change for each one of those that were mass edited. The next tool I like to show you is somewhat hidden from the menu, menu tools, and compare objects. This will open up the Compare Objects dialog, and we can compare one operation to another. For example, I'll compare one facing operation to another, and we'll compare both of those objects. Once we enter into this dialog, we can see it's only the settings that are different between the two. That's all it's going to show us. So in this example, comparing these two facing operations, we can see, our step over percentage is different, our cut pattern is different. If we wanted to match those operations, we have the ability to edit within this dialog. For example, I'll just change the cut pattern, and it's going to update the operation. We can go ahead and generate once again. With both Mass Edit and Compare Objects, you can quickly and confidently change multiple operations to be identical to one another, rather than having to edit each individual operation, which can lead to mistakes. You are able to make the changes in one operation dialog and apply it to many operations. The last hidden gem I'd like to show you is the use of solid models provided by your tooling vendor to create an internal CAM Pro tool holder. Having an accurate representation of your tool holder is critical to creating a collision-free program. However, defining a tool holder can be a tedious process, manually interrogating the model for the holder steps. The tool I will show you is specific for rotating milling holders. There are other tools available to handle fixed holders, such as broaching tools or turning tools. Let me show you the holder source option to create holder steps automatically. Now that we're back in CAM Pro, I'm going to import a tool holder that was provided by the manufacturer of the tool. And to do that, I'm going to use the reuse library, and I'll drag and drop my holder. Here we have a ER16 holder. Next thing I'll do is I'll use this holder to extract the steps automatically. In order for this tool to work, we'll need to create a link body of the holder. Since when we dragged and dropped from the reuse library, that holder was added as a component. It's going to need to be a body within the part navigator. To do this, from the Geometry tab, I'm going to select Wave Geometry Linker. That's just going to create a copy of that solid body. Here we have that link body, add it to the part navigator. Now I'll begin creating our tool. The tool subtype is unimportant since we are only concerned with the holder. So I'll just use a mill. And just since this is an ER16, I'll change the diameter. Again, this is unimportant, more visual at this point. I'll switch to the holder tab, and under the holder definition pull down, we have holder source, and we can select solid body. So I'll specify my solid body tool holder, and then I'll have to specify the mounting point. And the mounting point is where the holder will meet the spindle. So in this case, with a HSK63, I'm going to select the center point of this flange. One thing we'll need to do is reorientate our coordinate system. If I were to extract right now, we can see we're getting an incorrect model. So I will have to reorientate my mounting point so the z-axis is pointing towards the spindle. Then I can extract the holder steps once again. Now we have an accurate representation of our tool holder, automatically extract it. And put this side by side. Yep, looks very nice. Next thing we can do is save this holder to the library so it can be referenced when creating other tools that will use this particular holder. So I'll just give this a library reference name. As ER16 Solid Edge University, And then I'll export the holder to the library. Here we can see there's an information window. It's saying that this tool was created in the metric holder library. So if I cancel out and create another tool, again, I'll change the diameter of the tool just for visual reference. I'll switch to the holder tab, expand the library pull down, and now I can retrieve that holder that I saved to the library. Here we have our ER16 that was just saved. We can see a preview of the tool. We can look at other tools that are in the library as well. Yep, we're going to use that ER16 that we just saved. Additionally, we can see our tool is sticking all the way out of the holder. In the holder tab dialog, there's a tool insertion option, and we can add a value to this to position our tool correctly. So you have a very accurate representation of what is actually set up at the machine. Using the holder source tool available in CAM Pro will allow you to quickly and easily create an accurate tool assembly mirroring the real-world setup. With CAM Pro's digital twin capabilities, having the work holding and tool assembly matching the setup at the machine tool, you can create an NC program that is right the first time. If any collisions may occur, they will happen inside of CAM Pro rather than at the machine, avoiding downtime and costly collisions. To recap, if the manufacturing setup is not created with the solid edge part file, the reuse library will allow you to quickly add components to your manufacturing setup. If you have multiple parts, rather than programming each part individually, transform as an instance will allow you to copy the operations. Since the transform operations are instances of the parent operation, any changes made will automatically update. Using mass edit and compare objects will allow you to quickly edit multiple operations at once. And finally, the holder source tool will allow you to quickly create an accurate tool assembly mirroring the tool at the machine. I'd like to turn it back over to Karina as we head into the question and answers and closing section of the CAM Pro webinar. If you have any questions regarding CAM Pro, please feel free to reach out to me via phone or email. Thank you.
Thank you so much for your live demonstrations, Collin. Before heading into the Q&A section, I have a few more reminders as shown on the slide here. Siemens offers what they call the Solid Edge Startup Program, and since new businesses need access to the best tools and technologies that bring their ideas to market quickly but often lack means to acquire them, there's actually a solution that can help. The Solid Edge Startup Program provides an opportunity to receive a free full year of Solid Edge software with support and rich product features, and you can just contact me, karina.mcglasson@swooshtech.com, to see if you qualify. We also have resources available on our website, so be sure to check those out, concluding this event. And lastly, if you need to get into contact with our software Jedi, Collin, then you can just capture his information here on the screen. And please note that I'll personally be sending you all emails with the next couple of business days that include an on-demand session of this event so you can watch back at any time. Thank you again for joining us today as we prepare for you to become the next Solid Edge software Jedis while fighting your most challenging software Siths in the process. Now feel free to stick around for Q&A, or if you don't have any questions, you can of course leave this event. And in the meantime, I hope you all have a great rest of your week, and we'll see you next time. Bye everyone.